YouTube channel. In this video lecture, we are going to answer questions from great circles in 𝐃𝐞𝐐𝐭. I hope you have now been comfortable in solving all the great circle questions from Oxford RK.Bali and the questions that I have so far solved in 𝐃𝐞𝐐𝐭 book. Now let's continue with our progress and start answering questions 41 to 50. On a polar stereographic projection, the South Pole, a straight line joins points Alpha and Bravo. What is the true course on departure from point A? Okay, so it's a polar stereographic projection based on the South Pole. So let's draw this. Let's draw the representation of the Earth with respect to the South Pole. So let's say this is your South Pole. This will be your prime meridian, 0 degree. So this will be your 65 east longitude. This will be your 25 west longitude. Okay, and both are located on the same latitude, 70 south. So join them. Okay, now point number 1. This straight line joining for 65 east and 25 west is your great circle. Okay, when you go to higher and higher latitudes, great circles become great circles start changing into straight lines. Okay, so this particular line will be regarded as a straight line, Alpha Bravo. Okay, so next. So the true course on departure from position A is approximately what? Now this will be your line track, and great circle track will also be a straight line. Okay, now this is 70 degrees south latitude. So as the latitudes increase from 70 south to a new latitude of 80 degrees south to a new latitude of 90 degrees south, the great circles will start becoming straight lines. So let's draw this great circle here like this. Now we will have to calculate the direction of this great circle track. Now this great circle is this much, only this much. This great circle is nothing but a line track minus convergency angle. We know that the line track is 270 degree because both are located on the same latitude. You are traveling from the eastern hemisphere to western hemisphere. You will be flying a 270 direction. Convergency angle. So convergency here is D long. So 65 east, 25 west. So 65 plus 25 is equal to 90 degree into sine latitude, sine 70. So sine 70 into 90 is 84 degree 34 minutes. Convergency angle will be half of that is 42 degree 17 minutes. Okay, so convergency angle is 42 degrees. So 270 minus 42 is 228 degree. So the great circle track at A is equal to 228 degrees. So you are going to select that option which is closest to this value. Okay, next. On a direct Mercator chart, a great circle will be represented by a straight line, by a curve which is convex to the equator means bending towards the equator. A curve concave to the equator means a curve. Concave means bending away from the equator. Complex curves concave to the poles means curves that are bending away from the pole. So remember the properties of the direct Mercator chart. Direct Mercator chart, the great circle will be represented by a curve which is bending towards the pole, North Pole or the South Pole. So it should be, so that means it's bending towards the pole, North Pole. That means in other words, we can say it is bending away from the equator. Okay, so let's say this is your Mercator projection. Okay, and this is your equator 0 degree. So your great circle will bend between 2 points, will bend away from this equator, or towards the nearest pole which is North Pole. Okay, so we say curve concave to the equator. Concave means bending away, to bend away. Convex means bend towards. Next. Parallels of latitude except the equator are rhumb lines. What are rhumb lines? Rhumb lines are lines of constant direction. So all parallels of latitude, whether you take a latitude 90 degree north, 80 degree north, 20 degree north, 50 degrees south, whatever, even the equator, they all run in same direction, in one fixed direction, either easterly or westerly. A great circle is one exception, which is a great circle. One exception is both. Correction. Equator. One exception is both a great circle and a rhumb line. Okay, but except equator, all other latitudes are only rhumb line. So option alpha. On a direct Mercator chart, great circle will be represented by what? So just now we saw great circle can be represented by a curve which is concave, bending away from the equator, or a curve which is convex towards the pole. Next. Which one of the following concerning great circles on a direct Mercator chart is correct? With the exception of meridians and equator, great circles are curves concave to the equator, means bending away from the equator. The center cannot be that of the earth. They are represented by straight lines. They don't include the meridians nor the equator. So correct answer is option alpha. With the exception of meridians, meridian and anti-meridian together form a great circle. Equator is also a great circle. So with the exception of these two, your great circles on the Mercator chart will be represented in the form of curves which are bending away from the equator or bending towards the nearest pole. So option A. On a direct Mercator chart, a rhumb line appears as a small circle concave to the nearer pole, spiral curve, curve which is convex to the nearer pole, straight line. So correct answer is on a direct Mercator chart, a rhumb line appears as a straight line. Next. Which one of the following statements is correct concerning the appearance of great circles, with the exception of meridians, on polar stereographic chart whose tangency is at the pole? So on a polar stereographic chart, remember, great circles will bend, it will bend towards the pole of projection. Okay, so if the pole of projection is south pole, the great circles will bend towards that south pole. If the pole of projection is the north pole, the great circle will bend towards that north pole. So the higher the latitude, the closer they approximate to a straight line. Yes. So as you go to higher and higher altitudes, the great circles will tend to become like a straight line. Okay, so the lower the latitude, they become a straight line. They all represented by straight lines. They can never be approximated as straight lines. So correct answer is option alpha. Higher the latitude, that is basically above 70 degree north or 70 degree south, they approximate to a straight line. They tend to become a straight line. Next, a perfect straight line on a Lambert chart is a parallel of latitude, a rhumb line, a meridian of longitude, a great circle. So a perfect straight line on a Lambert's chart will be a meridian of longitude. Okay, all longitudes are straight lines on a parallel of correction on Lambert's chart. So this is another property. Remember, you will have to remember all the properties of direct Mercator chart, Lambert's chart, and polar stereographic chart by heart. Okay, how do rhumb lines appear other than meridians on a polar stereographic chart? So on a polar stereographic chart, rhumb lines will appear as curves. Now great circles on polar stereographic projections bend towards the pole. Rhumb lines do the opposite. They bend away, or they are concave from the pole of projection. From the pole of projection. Okay. Next. How are great circles shown on a direct Mercator chart? Same. Curves convex, which means bend towards the pole of towards the nearest pole, or curves, concave, bend away from the nearest, from the equator, from the equator. Okay, that's it. Right then, we'll stop here. We will do the next 10 questions in the next video lecture. I hope you have understood the 10 questions that I have solved in this video lecture. If you have any doubts or questions, let me know in the comment box of this video. Thank you for your time. See you.